Adding equations to a LaTeX Beamer presentation is a reasonably straightforward activity. We would merely make use of either the equation environment, as we would in many other types of LaTeX document, or we could include mathematics as inline equations. Now what we're going to look at here is not just including some mathematical equations, but adding a few additionals to this. And these are based on examples from the texample.net website, where in a LaTeX Beamer presentation, an equation has been included, boxes put around various parts of the equations, and lines connected from a bullet list to the boxes in the equation. So we're going to adapt that example to a statistical example, and we're going to make use of the model formula for a row column design. So the first thing we need to do is to make the TIX package available in our documents. So we use the use package command, and we're also including a couple of TIX libraries, the arrows, shapes, and fadings. This is so we can include various elements in the pictures that we're going to create. So we'll just scroll down to a particular frame. So what we need to do is, as we've got separate pictures and we want to link the nodes from separate pictures, we need to get TIX to remember some of the nodes. And the easiest way to do this is to make all pictures globally available. So we add this TIX style to every picture, remember picture. So this will allow us to refer to nodes in separate pictures and, for example, draw lines between them. We also add this little extra TIX style NA, where we've got a slight offset from a particular node, and this will allow our line to start slightly away from the text in the bullet point rather than overlapping with some of the text there. So we're going to create a slide here for a row column design model, and what we've got is a bullet list, but we've divided the bullet list into two parts. So the first part has got overall mean, and then we've got a node in here which we're denoting S1. So when we draw a line, it will start from next to this particular element. Then we've got the equation, and afterwards we have another bullet list. This time it's got 3 items, and these correspond to 3 other parts of the equation. And again, each of these have their own nodes labeled S2, S3, and S4. So then if we move back to the equation itself, so hiding in here, we can see the parts of the equation. So we've got the response, the mu, the mean, Ri, Cj, and Tk, which are the effects of rows, columns, and treatments respectively, as well as the epsilon ijk for the last part of the equation. So each of these has got nodes, which is given its labels D1 to D4, so that's going to be able to link S1 to D1, S2 to D2, S3 to D3, and so on. So we've put some information about the styles to appear in each of these nodes. So the fill is a background color, and the exclamation mark 20 is allowing us to make these transparent, so when they're put on top of the equation, they don't just hide the actual values. Then anchor equals base, that's anchoring the particular line that will join to this node, and rounded corners allows us to have something slightly more appealing than just a rectangle with the rather sharp corners. And then we've got the maths itself that appears in this particular node. So the next thing we need to do is to draw arrows between these nodes. So we create a separate picture environment, and we say it's an overlay because it's going to go on top of what we've produced already in our slides. And then what we need to do is we have a path for each of the 4 lines joining the nodes S1 to S4, which are the bullet list elements, down to D1 to D4, which are 4 parts of the equation. And then within the square brackets we've got information, so the out and in are the angles at which the lines approach, and bend left and bend right are a textual description of what the arrows and lines will look like. So if we go to our presentation, we'll see here is the example of what's been produced. So a line has been drawn from each of those bullet elements to a particular element of the equation, which is in its own coloured box. So as another example, let's look at a slightly simpler model, the multiple linear regression model. So what we've got on the next slide is we What we're going to do here is we're going to start off with the equation, and then on the next couple of slides we're going to highlight a particular part of it while making the rest of the slide appear to fade away. So we make use of the fading library in TeX. So we describe what is the inner and outer color, which basically correspond to how transparent, in this case, the bits which we're trying to highlight and the rest of the text is. So we're going 60% to 0%. So 0% means we can see it fully, 60% means that the rest of the slide gets darkened slightly. So we create our equation in a similar fashion. So we've got a node for each of the elements that we're going to highlight. So the intercept, the parameters in the model, and the model error term. And we define it with this fade inside so that we know once we apply the rules that we're going to use these colorings and the levels of transparency. So then we create a picture environment to actually generate these areas that are highlighted or not highlighted across 4 separate slides. So as we move between different slides, we'll highlight one bit and not the rest, and then move on to highlighting another area. So we make use of the path environment, and within these square brackets this tells Beamer that we want this to apply to the second version of this slide only, third slide and fourth slide, and so on. So to start off with, we create a rectangle across the whole of the slide, which basically is equivalent to not covering anything up. Then we move on to, on the second one, we're going to create circles around the first element of our equation. So the second part of the circle is a small bit inside it highlighted, and the first part here is the outer part that isn't highlighted or is hidden slightly in the presentation. So it's probably easiest if we actually take a look at the slides to see what's happened. So here we've got the equation itself with a bit of extra space put around the elements. So when we move on to the next bit, we'll see now we've got the first term highlighted, the rest of it is slightly blacked out. Move to the next slide, that moves along to the middle bit, and then over to the last slide. So that's an alternative way we could lay things out